So my name is Justin Stranatko. I'm a strategic solutions engineer with SingleStore. And so today we're going to talk about SingleStore, but naturally you're here to really talk about, honestly, multi-agent RAG. The idea here is, and let's just start off this way, just by a show of hands, how many of you have actually started working with Bedrock before? A couple of you, right? So the idea here is ultimately we're going to integrate both of them together, but to really start, what we want to do is let's actually first talk about what is SingleStore, the database kind of underneath it all. So SingleStore is a multi-model database solution. It's a hybrid database solution. What that ultimately means is it combines vector databases, search databases, analytics databases, and transactional databases, which is a lot, and all of that into one engine. Now the big point of this is ultimately, we started as an in-memory database, and it very quickly moved, right, into a column store OLAP, so the idea is fully hybrid. But here's the big one. Vector capabilities since 2017. So well before we think about ChatGPT or a lot of OpenAI and a lot of the new models that have come out, SingleStore has been thinking about vectors and AI for a long time. And so to give you a little bit of an idea, a lot of growth, but really ultimately, let's talk about this. SingleStore really sits at the heart of the nexus of intelligent applications, right? And so when we think about that, one of the first areas is of course going to be ingest. CDC coming from S3, Kafka, Hadoop, as well as Python, Spark, especially when we start thinking about the AI components. And it only really builds. The idea is it's a run anywhere architecture, and primarily we're here at AWS, and so in reality, AWS is actually our largest partner. We can deploy in a wide variety of ways, but honestly, AWS self-managed or managed service as a SaaS model is the primary one. And when we think about data types that we can actually work with, this is one of the biggest ones. It's basically a bring anything, do anything database. And ultimately that works incredibly well when we think about how it can gear for AI. When we think about applications that it can power, AI applications are at the heart of it. Same with machine learning. The idea is bring us your toughest challenges. We can do the easy stuff, but bring us the actual challenge. What's hard, what's difficult. Now when we build on this, this is the main idea, right? SingleStore as a company is actually quite a big pedigree when we think about the vector and AI space, and this is ultimately part of it. That first, back in 2017, was developed for two companies, right, so that vector capability. Goldman Sachs, right, a bank, and then Thorn. And so Thorn, if you don't know it, actually helps fight human trafficking, and so they partnered with SingleStore, and that's why we developed, ultimately, the vector capability, okay? And so if we build on that a little bit further, this is ultimately what we're trying to get at, okay? This is a great example of how you can take vectors and move away from just a pure standalone vector database and actually harmonize these together. By doing this harmonization, by bringing vectors with your relational data, your transactional data as well, you reduce latency, reduce cost, you reduce hallucinations, and ultimately that time to value, or that more importantly, that time to answer, is really what this is about. And so what we see here is just one example of a wide variety of customers that actually trust SingleStore, again, on the vector side, as well as on the relational and analytical side, okay? And so when we start to think about how SingleStore can really be used a little bit further, this is one of the best ways, right? SingleStore on AWS, that's really why we're here, okay? If we think about the wide variety of AWS products at play, from Bedrock, all the way through data source and data file ingestion, different databases that can work with. The idea is SingleStore ultimately can sit at the heart of that. It doesn't have to be the biggest kid in a very small sandbox. The reality is databases as a whole, whether we kind of see it or not at the moment, are ultimately moving in a way where they have to have interrelation or interoperability. It's great that you can do end-to-end, but the reality is if you can't integrate and work well with other databases, then it's really not going to work, right, long term, and SingleStore is a great example of that. And so this ultimately brings us to kind of the heart of the presentation. We've gotten through a lot of the stuff about SingleStore, and now we're getting a little bit more into the AI side. When we think about Bedrock, the idea here is you can really choose your own models, and a great example of this is Anthropic, right? Anthropic has models for Haiku, so fast, quick responses, Claude, right, for efficient responses, but still robust. And then you have Opus, right? And the idea with Opus here is that it's very complex. Difficult questions, really well thought out, important responses. And the ability to work with these models is incredibly efficient, right? Incredibly important. So the idea is you can take your data, pass it through a rules engine. In that rules engine, you can then take and say, this type of query, this type of question goes to model A. This type of question goes to model B. This type of question goes to model C. And it's great that you can do that, but ultimately you're only as fast as your slowest component, right? And so when we start to think about how we can actually directly implement something like this is it, right? What we have here, first and foremost, and you can think about it this way, right? Real-time ingestion of data, so we've generated our vectors. We need to take that data into the system. And so if we work with MSK, which is the managed Kafka service for AWS, we're going to take that data in, and we're going to ingest it via what we call pipelines. Pipelines, by the way, 15 lines of SQL code, and most of that is actually your credential. So if you have session tokens, there you go, another line. But the idea is this is easy to set up, amazingly flexible, and can ingest 10 million data points easily in under a minute, whether we're thinking vectors, standard data points, any events. And again, this will be continuously ingested in real time, and ultimately that data gets fed into SingleStore as your database solution. Vector, relational, everything together. And now you're thinking, hey, we were just talking about Bedrock, right? How do we bring that in? 2 lines of code, and you're going to see this a little bit later, but the idea is this. Bedrock can be called via an API, Bodo3 library if you're Python familiar, and if you're not, then ultimately you have engineers that can also help with this. But the idea is I can choose my model in Bedrock, and I can incorporate it into the database, ultimately as a bring your own model style, incredibly efficiently. And so that data can then ultimately be fed back into the model, and instead of stitching between multiple databases at the same time, you're going into one. Now, I'll skip over this a little bit, kind of obfuscate, but the idea is ultimately we can also build on that model as well. Data can still be coming in from MSK, but when you actually want to build on this a little bit more, we can have different models, right? So we have a Bedrock embedding model, we have our generative AI model, and if you're familiar with microservices, then we can also use things like Lambda as well for additional computation. The idea here is this is a tremendously flexible and easily deployable database solution, and it really is an end-to-end solution as a result. And so if I were to put this into perspective a little bit more, we've talked about the AWS side, right? There's a lot of services here. But in a traditional RAG or retrieval augmented generation, think of this as bite-sized AI. So if you're trying to go out and you're trying to build AI for your systems, whether we're thinking HR data or we're talking about data from any number of places within your organization, the idea is ultimately you have to cobble that data together. It's great that I have my end user and they have a question, but when I actually ask that question, I go to the transactional system, that OLTP system. I bring that data in. I go to the OLAP system, I bring that data in. I go to the vector database, and then I bring that data in. And each one of these introduces additional latency, round-trip latency. It introduces complexity. It introduces cost as well. And the point of this is there really is a better way. When we think about how we can ultimately bring this all together, this is the idea. Now think back to that right-hand side, right? Completely replaced. And so same end user, same Gen AI application. But instead of having to cobble together multiple systems, right, the idea is you're bringing it into one. And because you're only as fast as your slowest component, or more importantly, your slowest database, right? The idea is you can save yourself time and quite a lot of money. So you've reduced your complexity by simplifying into one and harmonizing into one system. The other thing is I can bring my vectors, and I can actually store my vectors next to my unvectorized text, not just in the same database, but in the same exact table. And when we start to think about schema evolution, because models change over time, the idea is this, right? In that table, I have model A, so that has my vector. So my text, my vector. From there, as I build a new model, or as I use a new model, a new vector is generated. I add a column into the table, and basically this is just a relational table. It's an RDBMS, right? So new column, new vector, new column, new vector. And the idea is now you actually have schema evolution. You can track the vectors against the models, and you always have the same text sitting in the same database. Okay? And so ultimately, what we're really trying to get at here is 3 major key developer areas, okay? First one is on what we would consider more of the lexical side, right? So this would be your traditional keyword or proximity or even fuzzy match searches. This is something that Elastic and Solar do really well. And in fact, SingleStore actually has the same exact engine. So the idea is bring your data in, and when we want to actually start working with that data, it's that much easier, right? It's all sitting in one harmonized place, and now I can add on a lot of additional search features. We can also build with faster vectors, right? So the idea is we can have now vector search, lexical search, and then when we bring this together, what we can do is something called hybrid search. Now I'm going to pause right here, we got a little bit of time. How many of you have ever heard of hybrid search? Right, a couple. So let's explain this a little bit faster. The idea is hybrid search comes in two flavors, okay? First one is we have our lexical search. You go into Google, you say New York Times, right? It brings you, this is just a word search, so it brings you to the New York Times. That's your lexical search or word search. On the vector side, we have our semantic search. You go in and start chatting to OpenAI, Gemini, or any of the like. The idea is you can harmonize these together to get the best of both worlds, okay? And when we do something like that, right, we bring text search, vector search, we can then have hybrid search. So hybrid search works like this, and it comes, again, two flavors. First one is I can do a lexical search, and that, when I pass that as context into my semantic search, narrows down the focus, right, the same way that we prompt the LLM, and now I have a much better response, right? I passed additional context into the context window depending on my LLM, and so I get a better response from that. The second way of doing it is actually by weighting the two together. And what we can do is, because SingleStore is all SQL, right, you can work SQL with vectors, so kind of a little bit of a newer piece. But the idea is, I can actually weight them. So if I love my lexical search, right, it's giving me better results, I can weight that with a 0.7 or a 0.5 or even a 0.6 in my SQL query. And on the semantic side, I could weight that as well. And what this allows us to do is it builds additional flexibility, right, on our LLMs, on our search criteria, and just genuinely on our ability to get effective, appropriate results. And so when we think about actually putting this into action, this is really it. Now from a high level perspective, this is what I was proving out. So I did a talk a couple weeks ago with Anthropic, kind of talking really similar idea in AWS. And I'm not going to show the full demo, but I'm going to show you snippets of the code, and I'll tell you ultimately what they did, okay? So first and foremost, this is ultimately the structure of the demo that I gave. The idea is you have our end user. They're going to interact with some sort of LLM interface, the same way we would with a RAG model going to OpenAI, or really any of the LLM models that exist in our companies or even outside. From that LLM, right, we have that question converted into SQL, and it's brought into SingleStore. Now, if we think back a couple slides, right, where I had OLTP, OLAP, vector database, that's not one database. That would be 3 or 5 or even 10 different databases that we have to bring together. And so when you harmonize all this, it makes life a lot easier. So the idea, again, data comes in, we ask our question, goes through the LM into SingleStore. From here, we query the results, right? If we're thinking of a standard text-based search, blazing fast. Average SingleStore response time, 1 to 15 milliseconds. And if you don't think that's fast, a blink of an eye is 10 milliseconds, and if you have really big fake lashes, 15 milliseconds, right? And so again, when we start to bring this together, you're only as fast as your slowest component. And so the base speed here, plus the augmentation that we get from choosing your own model, building out a multi-agent system within Anthropic or even any of the others, just gives you more efficient, faster results. And so when we think about the code, this is kind of it, right? So sorry for showing you Python code unprompted, but here's the idea, right? I can bring in SingleStore with just one URL. So I build out my, basically my OS environment, and then I'm going to connect. Now I've already given the instructions in the code to actually be able to connect this, so like my host, my port, my user, that's just from the database, right? So I put that in as the different variables ahead of time, and this creates my SingleStore connection. From here, now, I was using Anthropic. Anthropic doesn't have its own embedding model, which is a little bit of a surprise to me. So we're using Voyage AI. Now, the idea is when you input a question, you can ask a couple different ways, right? It could be embedded first and then it goes through, or you could get context and then pass through as the embedding for basically a response. Here, what we did was, again, we're just going to build out the embedding, okay? So that's the idea here. Again, pretty straightforward, and if you're ever wondering, by the way, if you ask me, all of this code, by the way, is actually on a public bucket. I also have all the data on a public bucket for you to run this as well. So after the talk, if you have any questions, happy to provide this. But I'll move on a little bit for the sake of time. So this is question number 1 that we were working on. So we pulled in a lot of Amazon store data specifically from Prime Video. We wanted review data, so getting all that text, generating the vector embedding, storing that in one single table. That's right, so all this data, one table, right? And so what we can do here is, and you actually see this right here, right? So we're using lexical search, so keyword search, to retrieve all the relevant reviews for a given title, and then we pass that as context into the LLM. And then from there, it gives us a result. So when we're doing this, this is actually the text, so this is what we were telling it to do. And then you can enter your title here. So in this case, I typed in Breaking Bad. That was part of the database. And this is the results, right? So we have everything related to that. Pretty straightforward, right? This is kind of as simple as it gets. Let's build it a little bit further. This is question number 2. This is actually a lot more complex. And not a ton, but still more complex. The idea is this. So this is the context I provided to the LM. You're a professional movie review aggregator. Your job is to take existing reviews and synthesize a 3-sentence output that summarizes the sentiment. And I wanted it to count as well because I want to know how many records are actually going in to generate its response. And so if we look down, here's the big one, right? I call Bodo3 as the client, and then ultimately I have my message dump coming out for the model. Now the result of this was 17 reviews, and it told me, because I was asking about Breaking Bad again, it said widely acclaimed. Absolutely phenomenal, people really loved it. And the fact of the matter is, and we have a couple minutes left, but the fact of the matter is this whole thing from start to finish, I mean getting the data, putting it onto S3, bringing it into SingleStore, generating the vector embedding, and ultimately building this took me under 2 hours, right? So what I'm really trying to say is from a simplistic perspective, when we think about a multi-agent system, sky's really the limit. You can bring in and use whatever models you want, but when you do it intelligently. And what I mean by that is choose a system or systems that work for you, and more importantly, that can scale with you. Complexity as a whole doesn't really scale well. And ultimately, when we think about how we can really push AI forward as a whole, whether we're thinking RAG or even full-blown generative AI, choose a system, again, that works for you, and more importantly, that you can actually work with long term. So with that being said, thank you all very much for taking the time out of your day to come here and listen. I really appreciate it.